brought a pencil.
No, I need to get one.
Caleb, do you have a pencil?
Yeah, you want
Like 6
Yeah, but can you give
Yeah.
Yeah, I found one too. I just don't know where it is.
Dude, I worked like that was like an expensive I did
2 pages.
my pencil.
Like 4.6 is 2
My
pages
first
long.
pencil I got all year. I think I went like halfway through 4.3 or something. So that's on this way.
I'm just trying to get 1 and 2 of them. Well, I got some of them done. I have.
All right, guys. We have 2 more kind of free response type questions to go over until we are officially done with Unit 4 and we're done with rational functions. So the end is near. Because the end is near, keep in mind that we kind of have a busy week. Tomorrow is going to be our free response day. Yeah. Wednesday is our partner quiz. Thursday is our review day. And then Friday and next Monday is going to be our unit test. So please keep in mind that schedule and those dates. In the meantime, these 2 questions I don't think are going to take us all period to go over, so you will have some time towards the end to work on some homework problems, ask questions if you have them, kind of get ready for our busy week. All right, so on page 286, we are given a table at the top. They tell us that it represents a rational function, and we also know that the denominator of the function is this quadratic expression. So we kind of have 2 pieces of information to use if we need to. All right, so based off of either of those pieces, can we find the domain? Can we think about what numbers we have to skip over? What's up?
It's hot in here.
Is it?
It's hot in this entire school.
I can shut the heat up.
You have the heat on?
Yeah.
What the heck?
That should help it a little bit. Yeah? Okay. Why? It's a whole or discontinuous thingy. Help them out. Vertical asymptote. There we go. So there's a hole somewhere and a vertical asymptote somewhere. So we're going to skip over those spots. While we're at it, since we know something's going on at -1 and something's going on at 3, can we just take a second and try to figure out which is a hole, which is a vertical asymptote? It might help us as we go forward. So maybe we can just anticipate or at least try to get ahead of the game. Yeah. Why? That's good. Okay, so if you look at the y value on either side, notice how they're extremely close together in value. So based off of our definition of a hole, the left and the right meet up at an open circle. If they're going to meet up, they have to have the same height. Okay, and that seems to be the case here. Okay, they're basically getting to the same height when they meet at -1. What's going on at 3? Yeah?
That's a vertical asymptote.
Because?
Because the heights are very spread out.
Very drastic. Okay, notice the left-hand side's very negative, right-hand side very positive. So we have that drastic change in direction. Okay, very negative, very positive, kind of signifying we go in opposite directions. So there's no way that could be a hole if you're going in opposite directions. So kind of process of elimination leaves us with vertical asymptote. I like it. So let's see if that can help us with 6. Does either factor in the denominator also exist in the numerator? So basically, do we have a factor that shows up in both places, on top and bottom? Can we start to think about maybe what the equation would look like? Go ahead, Emma.
X equals -1 would show up in the top as well. So it's a hole.
Okay, because x equals -1 is a hole. So if -1 is the location, then the factor would be x plus 1. Good. All right, if we have a factor in the top and the bottom, maybe you want to think about it as the little characteristic of 0 over 0, if that helps you. We kind of realize throughout the unit that that means we have a hole at that spot. What about 7 while we're on this factor train? Does either factor in the denominator not exist in the numerator. So it's only in the bottom, not in the top. If you thought about it, that would be like a number over 0. Yeah? Because? It's a vertical asymptote. All right, we saw that vertical asymptotes were kind of leftover factors in the denominator. They did not cancel out. So that means there's no way you could have that same factor up top. Okay, it's only in the bottom. Looking good. All right, based on the end behavior, okay, looking at the really far left and right of the table, can we try to think about where a horizontal asymptote might be? Where we might level off. You see it, Emma? Yeah?
Y equals 2.
Because? There we go. Okay, looking at the very far left and right points in the table, notice how we're getting drastically close to 2. Okay, we're approaching that value, but not necessarily reaching it. So y equals 2 because the far left and right points approach 2. We hanging in there a little bit? We didn't lose a lot over the weekend? No, I'm hoping not. All right. Last one. What must the leading coefficient of the numerator be? We're just looking for the top leading coefficient. Yeah?
4.
How'd you get it? That's good.
Since the horizontal asymptote is 2, the leading coefficients of the top and the bottom are divided to find the horizontal asymptote.
All right, hold on. The horizontal asymptote is at y equals 2. So the leading coefficient of the top and bottom must divide to get 2. So how did that lead you into 4? Okay, we haven't really used this piece yet, and this is probably why, because we only need it for the last one. The expression in the denominator is given to us at the top. So we know that the leading coefficient on the bottom is 2. And we know whatever we divide by 2, our answer should be 2. So what number divided by 2 gives you 2? That would be 4. So the leading coefficient of the top must be 4. Since the leading coefficient of the bottom is 2. We got a little wordy there in justifying it, but I think we can write it out. If you were asked to do this by yourself, how do you think you would have done?
I agree.
Not well? No, not at all?
If we remember, then
Where did we get lost? Or did we just need a review question? What?
The last one.
This one?
Yeah.
We were okay with the previous ones? Yeah? Okay. So maybe let's think about this. So the leading, whenever you see leading coefficient, okay, at least in terms of these rational functions, that's cluing you into horizontal asymptote, because that's really the only characteristic that we've talked about for rational functions that dealt with a leading coefficient. And if our horizontal asymptote is at 2, since that's somewhere other than 0, we know the degrees have to be the same. And to find the horizontal asymptote, we would divide the leading coefficients. So we're trying to figure out what the top one is, and we already know what the bottom one is since they gave it to us at the top. So somehow this division should give us the horizontal asymptote at 2. And thinking about it, that would be 4. Okay, I understand whenever it comes to a free response question, you're like guaranteed to have one thought-provoking one part, and that's probably this one. Okay, so as long as you can do the majority of it, that's fine. Okay, there's going to be some thinker in there at some point. You're bound to have it. All right, let's try another one. This time we have a graph. Okay, no table, no equation, just a picture. They don't really give us any information at the top other than it's a rational function, which we can clearly determine based off the picture anyway. So not really much to go off of. Can we determine domain and range? What numbers do we have to skip over? Yeah.
-4, -3.
Because?
-4 is a vertical asymptote, and -3 is a vertical.
All right, so in terms of the domain, okay, the x values we have to skip over -4, -3, because we have a vertical asymptote or a hole at those spots. What about for the range? Which y values do we have to skip over? If it helps, maybe drag your pencil low to high. Go to Autumn.
-7 and 2.
Because? That's good.
The whole and then horizontal asymptote.
Okay, so again, that hole, okay, we have to skip over it. This time it's y value. And then the horizontal asymptote is another y value that doesn't exist. So we'll skip it. So far, so good. All right, what factor is in the denominator but not the numerator? So if you think about it, this would be an example of a number over 0. Good, Emma?
X plus 1.
Because?
There is a vertical asymptote at x.
There we go. All right, speaking of factors, 12 is asking us for a factor that's in the denominator and also the numerator, so in both spots. Meaning if we were to plug something into equation, even though we don't have one, we'd get 0 over 0. Can we think of the factor? Go, Keith.
X plus 3.
Because?
Just the whole that
There we go. Whole is at x equals -3. All right, 13. What factor is in the numerator but not the denominator? So in this case, if we were to plug that number in, we get 0 over a number. This one might be a little tricky. You want to do, Emma?
Is it x minus 0.5?
Okay, so x minus a half. How'd you get that?
Because there's an x-intercept at what seems to be a half?
It seems to be. Yeah, okay, because it is an x-intercept. Okay, so if we look at the graph, we know that 0 over a number represents an x-intercept. If we look at the x-axis, something is going on right there. We don't really know where that is exactly because it's not on a tick mark, but an educated guess would probably make it 1.5. Okay, so we'll make sure that this is what we put down now, but when it comes time to actually write the equation, we may have to go back to the drawing board to make sure some other characteristics actually check out and make sense. So for now, it's an educated guess, but we'll go ahead and check our work in a little bit. So this is how you can initially write your factor. Can we rewrite it as some other way? Yeah?
2x minus 1.
2x minus 1. Okay, so this is technically correct. Okay, I would not mark it wrong, but this factor is going to be more useful for us to use later on when we have to write the equation, because if you left it this way, you may miss a characteristic or two. Again, they might not make sense. So just be aware that you can slide the 2 out front to rewrite it. Okay, so this one is maybe the one we'll use later on. All right, if A is the leading coefficient, here we go again, leading coefficient of the numerator, B is the leading coefficient of the denominator, what do you think would happen if we divided the two? Leading coefficients are kind of cluing us into what characteristic? Yeah? A horizontal asymptote. Okay, so if we were to divide A by B, what do you think we should get? 2. Because the horizontal asymptote is at the y value of 2. All right, so I think we picked apart every characteristic. Let's see if we can bring it all together, because the very last one is asking us to write the equation in standard form. So that means get rid of all the parentheses. Okay, make sure it's expanded. Now we'll start with the factors though, because those were easily identified in the previous questions. So we said x plus 4 should only be in the bottom. X plus 3 should be in the top and the bottom. And 2x minus 1 should only be in the top. Now remember, this was an educated guess for the factor. Okay, let's expand it and see if it actually checks out. If it doesn't, we may have to change this factor. All right, if we go through FOIL, we'll get 2x squared minus x plus 6. So that'd be 5x minus 3 all over x squared plus 7x plus 12. Can we double check this equation just because we weren't quite sure about this 2x minus 1? What are some ways we can check it? Yeah?
Find the y-intercept by dividing the constant.
Constants. Okay, so negative 3 divided by 12, negative 1/4. Does that seem like our y-intercept on the graph?
Yes.
I'd say so. Okay, you realize though if we got like negative 6 or 10, we drastically did something wrong. Okay, so I would say, again, it's a little educated guess, but it seems to make sense. All right, is there another way we can check it? Just to verify? Good, Emma?
Dividing leading coefficients to make sure that it gets
The horizontal asymptote. Okay, our degrees are equal, so we can divide the leading coefficients. 2 divided by 1 gives us the horizontal asymptote that we said should be at 2. Okay, based off of what we said for number 14. So it seems like even though this factor of 2x minus 1 was an educated guess, okay, based off of that x-intercept, it looks to be the right one because all the other characteristics are checking out. If you had to do that one on your own, how do you think you would have done? Fine? A little bit better?
More than fine.
Good. I'm excited. Okay, so tomorrow, free response day, and quiz and test coming up later this week into next week. Remainder of the period can be questions and homework time.